Well, thank you all for coming to this lunch and learn. Appreciate that you guys made time. We got a full house here. And today's learning objectives, we're going to learn about building automation system technology trends and better approaches to application and control of air terminal hydronics and controls for VAV zones. So our learning objectives today are: what external trends affect air terminal zone control application today? How does energy conservation lead to larger air terminals and reheat coils? What technical difficulties arise from larger air terminals and reheat coils? How does it start a domino effect? Zone controllability issues, quality of the components supplied, increased life cycle costs of the zones and equipment, time to completion of a project, increased risk, finger pointing, and how are these difficulties mitigated with a solution-based approach? So the first thing that affects VAV terminal design, obviously, as engineers, you're all getting a lot of pressure now to design around very energy efficient buildings. So obviously the first thing is fan system pressure, because it affects the coils and the boxes. Fans account for about 15.2% of the energy breakdown in a large building. Hot water is 1.6%, space cooling is 23%. And ASHRAE standards are trying to limit the fan power, and basically it all comes down to fan system pressure. You guys know most of this stuff. And what's happening is it's favoring larger ducts and larger terminals, because that's kind of a no-brainer on how to bring down, horsepower. But at the same time, what ends up happening is the architects always want smaller duct and equipment. Yeah, I see everybody kind of shaking their heads in here. So there's always a balancing act where the engineer needs more space and the architect wants to do all this fancy stuff, and they hate the engineer because HVAC systems take up all the space in the building. The second thing that affects the energy conservation on these terminal units is obviously the hot water coils. And there's sensible coils, and we have the air in and the air out across the coil. And obviously, if we vary that, we may have to go with a larger coil because we won't be able to get the performance through there. And obviously the water in and out of the coil. And what ends up happening is that a lot of the new equipment out there, the condensing boilers, heat pump chillers, where they make 42 degree water on one side and 105 to 140 degree hot water on the other side, heat recovery, and so with this equipment that's more energy efficient, a lot of designers have to reduce the condenser water temperature from 180 degree water temperature, but down to 140 or 105 or 120 or whatever you can do feasibly, and that causes problems because you still have to meet the same ambient in the room. But from a thermodynamic standpoint, if you're going from 180 degree water down to 140 or 120 degree water, obviously you're going to have to do something with put some sort of more heat exchanger surface. So what happens there is you get lower distribution temperature, which will lead to a low system delta T, which is similar. That's what happened in cooling plants. And so the answer really is you need more heat exchanger surface or heat exchanger area. So how do you do that? Well, here's some of the problems. So there's a chart here on the right here, and what this basically talks about is you have your velocity in duct feet per minute over here on the right, then you have your flow error in feet per minute on the left. And what this basically says is 1,000 feet per minute, you can measure fairly accurately the airflow at plus or minus 5%, which is about 60 feet per minute. But as soon as you drop that airflow below 1,000 feet per minute, it goes up to 200 feet per minute, and it becomes a 20 to 25% error. So it's very hard to measure accurately below 1,000 feet per minute. If you can't measure accurately, how are you going to control the zone? And then you have what happens with the zone controllability. Everybody's kind of shaking their heads again, okay? So what happens is, if with reducing the condenser water temperature, you can add more rows, but if you add more rows, what happens? The air pressure drop shoots up. Yeah, everybody's shaking their head again. So it can be substantial. A 2-row coil that has an air pressure drop of 0.04, if you put in a 3 or 4-row coil, the air pressure drop can go to 0.9 or even an inch. So that defeats the whole purpose, because now you take a hit on the first slide, which we talked about, the fan pressure. So the next thing was, well, let's just make the coils larger, put more face area. So we put more face area, we can keep them to a 1 or 2-row coil, not go to a 3 or 4-row coil. But there'll be some issues with that, because as you oversize the heat exchangers, what happens? You have to oversize the VAV boxes, and you basically lose the turn down capability, because a VAV box is only good for about 5 to 1, 6 to 1 turn down capability. So you go below 1,000 feet per minute, you're basically going to have all sorts of problems. So low velocity, hard to measure the flow. Oversized boxes, hard to regulate, the damper turn down ratio. And then if you get into hydronics where you increase the GPM versus increased face area, what happens then? That's right, you take a hit on your pump horsepower. So it's like either way you turn around, you're trying to design for an energy efficient building, and it's really a balancing act. And a lot of this will result in poor temperature control, because what happens is you have to size all the components commensurately: the air valve, the coil, the hydronics, the control valve, the VAV controller, legacy software. And what happens is they're all typically supplied by separate entities. And then you have to try to coordinate all those entities, and it's very difficult to do that. So basically this slide kind of epitomizes what happens today on a job site. So you have typically a VAV box manufacturer that comes in, and now let me ask a question: do you guys size your own boxes, or do you typically give them to the reps? Okay, I see a mixture. Some of you guys are sizing your own. A lot of you guys are giving them to a lot of you guys don't have time to exactly don't have time to sit down and spend 10 minutes on each box. If you have a job with 500 to 1,000 boxes, it's pretty time consuming and cumbersome to go in and size these boxes. But anyway, what ends up happening is a rep typically, what do you think they're going to select? Are they going to select the bigger box or the smaller box? If they had a 10-inch box and they could, and if they had 1,000 CFM, you can go with a 12, 10, or 8. Which one do you think they're going to pick? That's right, they're going to pick the 12. And no, not just because of price. Okay, yeah, of course, all the reps want to make more money, but think about it from a noise criteria, right? The bigger the box, you don't have any noise issues. So again, I'm talking about the balancing act. But if you oversize the box, then what happens is the hydronics guy comes in, and they basically have to size the hydronics based on the performance of the coil and the box. Then what happens, the controls guy comes in the back end, he has to supply the controls valve, figure out the CCV, and then the controller. And then of course the mechanical contractor comes in, he has to basically take all these components and act as the integrator and try to make it all work. So what ends up happening a lot of these times is if the box are sizing correctly, they go on the schedule, that's what ends up going through, causes a domino effect, and then leads to zone controllability issues, which is high risk, low time to completion of a project, low value, increased cost of ownership, and of course, yeah, you guys are all kind of laughing. You get this, the finger pointing, not my fault, not his fault. So if the zone doesn't work, you guys say, you call the controls guy, you say, hey, fix the zone. Controls guy say, hey, it's not my fault, it's the balancer's fault. Balancer's fault said, not my fault, that's the guy who sized the boxes, and you get this finger pointing, and nothing gets resolved. The other interesting thing is the Construction Industry Institute did a study, and the bottom line, what this basically says is manufacturing technologies are 66% value add, 26% waste. Construction technology advances 10% value add, 57% waste, which is a $1.5 trillion US discrepancy. Basically what this says is the more things that you can manufacture at the factory, the more value you're going to get out of it and the reduced cost it's going to be. So this kind of again, we're talking about what happens on a typical job site. So that one slide we went back to, and you see all this happening. That can't be very efficient from a contractor to do it versus try to do it at a factory. The other thing is, you guys all have your customer, which is the end user, engineers, and what do they want? Well, here's some of the things they want. They want optimized logistics, they want high quality, reduce change orders. They hate change orders, right? How many times do you hear your customer complain about the change order? And a lot of times the mechanical will come back and they'll try to stick who with the change order. That's right, you guys, the engineer, right? So single source responsibility is a big thing, lowest construction cost, lowest life cycle cost, technology, fastest time to completion, standardization, data retrieval, and basically in a word, they want value, all right, value. So what is we identified a lot of the problems, okay? So now let's talk about a solution-based approach, right? How would you guys like to hear that? An actual solution, right? So what happens is the solution is really you want to design the air terminal hydronics and controls as a single HVAC subsystem. You want the air valve, the airflow sensor, the transducer, the VV controller and software, the coil, the hydronics, balancing valve, control valve, legacy control system, all in one. And you guys are saying, well, how do I do that? Well, I've got to deal with 5 or 6 different vendors. You don't want them as separate components or by separate entities. This will reduce life cycle costs, and you want basically single source responsibility. And the bottom line is the controls contractor is ultimately responsible for zone control and the life cycle of the building. You guys agree with that? Yeah. So I see, okay, pretty much everybody in here agrees that the controls contractor is going to get the call when the zone doesn't work, right? Okay. There's also some new standards coming out, ASHRAE Demand Ventilation 62.1, Energy Standard 90.1, and 195P for proposed. What 195P does, you guys probably get all the box manufacturers that come in here and they tell you how great their airflow probe is, right? You're all shaking your head. And I used to say, well, so what? I mean, who cares if your probe can go down to 0.001? And is that at plus or minus 5%, or is that at plus or minus 25%? The weak link is the transducer and the controller. So what good does it do if your probe can go down to 0.001 if your transducer can only go down to 0.002 with a plus or minus 5% accuracy? So what 195P basically says is that the airflow sensor and the transducer / controller now have to be tested together for the performance, not individually as being done as the case, and you write a performance-based specification. So this is the traditional way, and the bottom line is, what if you could get all of this from a single source supplier? So various trades, sheet metal, plumbing, controls, electrical, the segmentation, you have an airside rep, hydronics rep, a controls contractor, mechanical contractor, all trying to supply this. Increased risk, slow, laborious, cumbersome, expensive, inefficient. So if we could take all this stuff that is being done now the traditional way and get it from a single source supplier, introducing the zone control unit by Siemens, a better way. So basically, this is what you see, this is what you get, this is how it ships, validated, commissioned from the factory, ships to the job site 100% defect free. It's an efficient turnkey solution. It reduces your cost of ownership, decreases time to completion, mitigates risk, adds value, reduces cost. And the bottom line is it's single source responsibility, buck stops with Siemens. So what is it? You can get single duct VV boxes, fan power, low profile. We can do UBC certification, which is basically the product is on a shaker bed and it shakes violently, and then once it passes at 1.5 allowance factor, then you basically it's certified for seismic. This is a great thing because it eliminates risk, helps bring down insurance premiums in the building. You get single side access. You can do custom piping. You can get it with no O-ring. So this is with O-rings. A lot of the engineers, a lot of the end users don't like the quick connect kits because quick connect kits have O-rings, and then after about 3 to 5 years, the water treatment starts eating them up and you start getting leaks. So a lot of the engineers around the country are starting to go to these the way it was done the old way, where you have dielectric unions and you have no O-rings, which means instead of having 4 sweat connections, you have roughly 18 sweat connections. But again, we're prefabbing these in a factory. Where it might take a contractor 6 to 8 hours to do it, we can do it in roughly an hour. You get bypasses, but the bottom line is the owner's wish list becomes affordable. I'd like to play a video for you from HCA hospitals. They actually actually are using the VRUs. The first time they tried to do it, they had a mechanical contractor try to supply them. The mechanical contractor said it didn't pay back. And then the second time, they actually had the controls contractor supply it, and they found it saved about $2 a square foot. And the reason it worked was because when we built a sample, shipped out the zone control unit, and then they had 4 mechanical contractors bid on it, so instead of taking 4 to 5 hours to install it, you'll see here it only took about 10 to 15 minutes, and they all knew they were bidding against each other, so they all had to sharpen their pencil. So instead of coming in and throwing in, $1,000 for this, $500 for this, they look at the ZCU, and they go, oh, well, we only need 10 minutes, for this, $25, 10 minutes for this, $25. So now we can install it for a lot quicker, and then it's paid back. So with that, let me just play the video for you. It's a 5-minute video. It was made internally by HCA, and it's pretty compelling.
Either available as a VRU by Johnson Controls, and VRU stands for Variable VAV Ready Unit, or as a ZCU, a Zone Control Unit by Siemens. Normally what you would see show up on a job site is a significant amount of pieces of hardware as defined by the actual VAV box, control section, a square to round transfer unit, a control valve, a isolation valve package, a hose kit, a control box with the controller inside, as well as a discharge air temperature sensor. In this case, all these pieces have been connected and built together in a controlled environment, which significantly improves the quality of the unit. The unit is also shipped pre-pressurized. There's a pressure gauge on the unit which displays at all times the pressure inside the hot water coil and the valve kit, and will tell you that even after installation, before hookup, that your coil integrity is in place. The boxes are shipped with the controllers pre-programmed, which means that the airflow is already determined at the manufacturer's location. As a result of that, this VAV box can only be installed in a location it is intended to be, as identified by its unique identifier. When on site and ready to install, the units come with aircraft cables. It makes it extremely easy to hang these units and level them. It takes about 10 minutes. Critical to the success of using this product is the working together between the design engineer, the mechanical contractor, and the controls contractor. The roles of each of these entities is a little different than in the traditional configuration. Most of the work is normally done by the mechanical contractor, where over here the controls contractor takes complete responsibility for sizing and sending the proper units to the job site. The pre-programming of the controllers, the connected thermostats, the control of the discharge air temperature sensor, as well as the control valve, is all taken care of prior to the unit arriving on site. Now, how much time did it take to hang this VAV box?
It only took about 15 minutes to lay out the hangers and to put the box into place.
Would you say this is a significant time saving over a traditional installed VAV box?
I would. The assembly comes with the hangers already assembled to it, and all you have to do is put the anchors in and extend the hangers to it.
Is it difficult to deal with the aircraft cables, or do they make it pretty easy to level the unit?
The gripple system has an adjustable latch that you can adjust the cables and adjust the height as you need to. It's very simple.
Let's go over some of the advantages of a pre-manufactured VAV box one more time. One of the advantages of this unit is that the control box, as well as the control valve and other isolation valves, are all mounted on the same side on the unit. Most of these get hung in corridors where accessibility is an issue. By being able to mount this one box in the corridor against the wall, you only need one side of accessibility. Another issue often is that the cover panel on the control box disappears. This is a sliding panel that actually cannot be removed from the box, allowing for the panel to remain in place during the life of the box. In addition to this, when the pre-manufactured VAV arrives on site, it has been tested and calibrated. As I mentioned before, the unit gets shipped pressurized, and therefore you know that the coil integrity is in place at the time of the arrival, and the quality workmanship of the soldering joints in a controlled environment in a factory is far superior to trying to do this on a ladder at the job site. Besides all the quality improvements that the pre-manufactured VAV box has to offer, there's also a significant monetary advantage. The time savings with the unit being on site and being able to be installed in a very short time frame significantly reduces the cost for the mechanical contractor to install these units. The key to the monetary savings is the cooperation between the design engineer, the owner, the mechanical contractor, the general contractor, and the controls contractor. Very early on in the design process, all parties involved need to decide which route they want to go. If they decide early on to go with the pre-manufactured VAV box, there are significant savings to be had.
So I think that explains it, pretty well from the, owner's perspective, when they basically had the controls company supply the prefabricated VAV boxes. And as you can see, it's not just Siemens that can do it, but also Johnson Controls, so you don't have to worry about sole sourcing anybody with the multiple names. So basically the bottom line here is, in order to see this value and capture it, you really want to move the VAV terminal unit coil hydronics into Division 23 and make the controls contractor responsible for it and have the mechanical install it. Basically, how many of you guys you specify lab valves? You all do that, right? Okay, so what happens in a lab valve is when you do any type of life sciences, the air valve is always part of that's right, the controls part. Okay, why is that? Because it's a critical environment. If you size the air valve incorrectly, it can mess up, the performance of the zone. So basically, you'd be doing the same thing as a lab valve, critical environment for life sciences, but zone controllability in buildings now with energy and everything else we went over, that's becoming a major issue as well. Several controls contractors are offering pre-pipe VAV units for competitive bidding. So obviously Siemens can do it, Johnson can do it. Other controls companies can team up with box manufacturers, just like other controls companies team up with lab life sciences, lab type manufacturers. You get risk mitigation with single source responsibility. And the bottom line is, if you ask your customer, the end user, who do you prefer to warranty the zone, the controls contractor who has the life cycle of the building, or the the contractor or the rep? Well, obviously it's a no-brainer. It's always the controls contractor, and the controls contractor is always responsible for proper VAV zone control. Who always gets the call if the zone doesn't work? It's always the controls contractor. So at least this way, allow us to have input in helping size the air valve, the hydronics, the control valve and everything, so everything works together. The most expensive component on the ZCU, what do you guys think it is? That's right, it's the controls and it's the labor. So it always cracks me up when the VAV box manufacturers say, oh, we can mount and wire the VAV controllers. Well, what are they mounting and wiring? All they're doing is taking the controller, sliding it over the damper shaft and putting a screw through it. That's it. They're not wiring the control valve because it's not pre-pipe. So with us, what happens is we can pre-pipe this up. We can put the control valve on here. By putting the control valve on here, we can then wire it back to the controller. We can put the airflow sensor, wire it back to the controller. If everything's wired back, we can now program it, and then we can actually factory test. We can actually put power to these things, run the program, and make sure the control valve is working correctly and the actuator is working correctly full cycle. So then when these things arrive at the job site, they're 100% defect free. They go in, and they go in real quick, and we don't have to go out to the control valve or the box 3, 4, 5 times like we're doing right now on a typical job. So this is what the benefits of the factory programming and commissioning do. And we're going to save money by validating each unit at the factory versus doing it out in the field. And then we also do an integrated project delivery approach, which saves time and money and reduces time to completion of a project. And what that is we ship the units out just in time to the job site by quadrant or zone. And the other thing is the engineers and end user standard is going to be the same regardless of the installing mechanical contractor. So if you come up with a standard, it doesn't matter who the mechanical contractor is or where the geographic location, all the product shipped is going to be identical per the standard. BIM coordination becomes easier because all our coils, all our hydronics are 6 inches on center on coil on the piping design, regardless of how big the coil gets, and we'll show you that in the next couple of slides. And we can also do custom piping configurations, including no O-rings for extended life cycle. And we also give you a data retrieval system and a spare coil pack piping structure, which reduces the cost of ownership. Just wanted to put this slide up here to talk about, everyone talks about chillers, right? Because chillers they think it's the most expensive thing in the building, right? It's the biggest and they think it's the most expensive. Well, a chiller, 500-ton chiller is going to run you about $300 a ton, is $150,000. The rule of thumb is 1 ton of cooling equals 1 ZCU. So if you had 200,000 CFM of air side, which equates to 500 tons, 400 CFM per ton, it's 500, that's 200 CFM. Divide that by 400 CFM per zone gives you 500 ZCUs. At $1,600 each is $800,000. So $800,000 versus $150,000. That's how, you know, how much money these ECUs are really costing in a building and how much the contractor has, you know, squeezed in there. Put it in perspective, control zone pricing is going to be about $1,400 a zone. I'm not sure what it is here. It could be $1,200. There's other areas that are $1,600 to $1,800 per zone. So for $200, you get the entire, you know, VAV box, the you know, everything on the ZCU. And a lot of this comes because we can factory program these things. They save us a lot of time in the back end. So is it worth a $200 ad? Well, the question is, you know, the answer is, of course it is. The integrated project delivery approach, we do a cradle to grave. Well, we like to sit with you and develop a standard, kind of what we did with HCA. And like they wanted stainless steel isolation valves, ball valves. They wanted like a Cadillac standard, but we were able to provide it to them at a reasonable price. So we lock in whatever the standard is per the end user's requirements, or you can do your own engineering standard, and then we can give you a fixed price because, you know, we know it's a product. So we can give you a fixed price whether you buy one or you buy 1,000 of them, okay? We then will help, we want to assist with engineering the ZCU, so make sure that it's engineered for optimum performance. We'll prepare all the submittals, which are extremely detailed, hydronics, controls, and air side, I mean NC, discharge, radiated, all the different GPMs, everything's right there. We then build we manufacture the ZCU with the submittals and standards, factory program each one of the units. We then factory commission, power up, test, and validate. We expedite the delivery using lean manufacturing, and we ship it just in time by quad and zone. And then we supply a data retrieval system on a memory stick that has all the product data, digital pictures, everything all inclusive. Some of the options you can get disconnects, transformers, controls, pressure independent valves, auto flow valves, bypasses, sheet metal transitions, hose kits, custom piping, you know, pretty much whatever your customer would like, we can pretty much do, and we pretty much have done it for all sorts of different facilities around the country. The standardization, and it really helps with BIM coordination and fastest time to completion. This is a competitor's coil, and you notice that the inlet and outlet are at very top and bottom of the coil. What we do here at Siemens is, here's a 6-inch, 8-inch, and 10-inch. You notice how all the piping, we come right off of this thing with a tube bender, and everything is 6 inches on center, regardless of how big the VAV box or the coil gets. And that's important because now what happens is, the BIM coordination, we know that all the hydraulics will be 6 inches on center, 3/4 inch pipe, 1/2 inch control valve. So it makes BIM coordination a lot easier. We also put air vents at the top and the bottom of the headers, so you can fill reverse these things. And of course the air vents at the highest point, so for easy drainage. And pretty much the same happens with you know, the software program graphics. Everything's going to be consistent, going to be the same. So we're trying to, you know, standardize and everything. And then we use these 14 gauge handle brackets that actually add rigidity and support to the hydronic structure when it goes out in the field, so you don't get the stress cracks, so you don't get the leaks. And you can put a human hand through here, so if you can use it for material handling, you can put a forklift, you know, unistrut, you know, whatever, and it also protects the product during shipment. The factory commissioning and validation, talked a little bit about this. What we do is we like to ship everything 100% defect free from the factory. We program, power up, commission with validation packages specific to each unit. We take a digital picture of each ZCU, both on the hydronics and on the electrical side. We pressurize, the coils are pressurized overnight. They ship to the job site with a pressure gauge. And all the controls, hardware, software, powered up, tested, run full cycle. Actuators are stroked full cycle and validated. And we have validation sheets of each ZCU that list the performance data specific to each unit. They're adhered right on the unit itself. And we also get supply a data retrieval system. The reason we take digital pictures of every unit is a lot of you guys here, engineers, you probably have to go out afterwards and play policeman. And you guys are all shaking your heads. You probably go up in the interstitial and the spaces up there, and you're going, you know, you're at the hydronic coil. You go, wait a minute, there's supposed to be an isolation valve here, and where is it? Then you go down 100 feet, and it's like, oh, it's over here, but it should be over here. Or, you know, we submitted on a Nexus, but this one's a Griswold, and this one's you got different, you know, hodgepodge. So digital pictures basically do is to validate and to keep you guys from going up there in the interstitial and stuff and looking at the box and stuff. We can send you the digital pictures, and that validates what's exactly is on the project. About 3 months ago, we had a contractor actually call us, and they sent us a picture of a box. It was a three-way configuration, and he said, "Hey, you shipped us the wrong box. We were hanging a three-way. It should have been a two-way." We said, "Well, is it possible that you had, your guys hung the wrong box?" He says, "Well, you call me a liar." I says, "No, we're not calling you a liar. We send them the digital pictures." He goes, "Oh, you guys take the digital picture of this. Oh, my stupid sheet metal guys, they don't know." They start, "Yeah, you guys are laughing." They start blaming the sheet metal guys. But if we didn't have those digital pictures, what ends up happening? We get into a pee-pee match with these guys, which nobody likes to do that. So the digital pictures are actually a great way to keep everybody honest in the job, and also makes your guys' job a lot easier, and it also goes into a data retrieval system. So what is the data retrieval system? Well, it's basically job specific. We give you a memory stick, and it has all your submittals, digital picture of all the ZCUs, CAD drawings, parts lists, software files specific to each zone, performance schedules, and we ship you a spare coil pack stick. Now, what is the spare coil pack stick? Well, basically it's your return valves and your supply, and we build them in a single stick assembly, which allows us to seal the ends, pressure test it, and we can ship it to you with a pressure gauge showing that there's no leaks. So what happens right now in a project is, if a zone goes down, the technician has to go up, pop the ceiling tile, and what ends up happening is has to go up there, identify the faulty component, if it's a controller, or if it's a valve or an ATC valve. You basically have to go up there, take it out, isolate the circuit, then you have to go find that part, locate the part, then you have to schedule again to go up there and install the part, and you could be down for 2 weeks to a month and a half. With our system, what happens is the technician takes the iPad, goes onto his network, pulls up VAV1-1, pulls up the digital picture, goes, oh, he knows exactly what he's looking at. Grabs the spare coil pack stick, walks up, pops the ceiling tile. If it's a bad controller, you can take the controller out, you can have the new controller shipped. You go in, you pull up the software files for VAV1-1, you download that software file, you put it back onto the controller. You don't have to worry about trying to figure out what program to go in there. If it's a bad hydronic part, you take the coil pack with you. If the control valve's bad, you just cut it here. You cut it on the ZCU, and then all you have to do is basically press fit in this piece, or sweat it in. You're done in 10-15 minutes. So again, it mitigates risk and reduces life cycle costs. Big deal. A lot of people love this, and you guys are all shaking your head and smiling. Yep, well, it's available. And that next thing is, it's not enough to make a great product, but you have to be able to ship it everywhere in North America without damage. You have to do it economically, so we have a way of double stacking the ZCUs with individually strapped down, and we can put 5 to 10 on each pallet, which reduces the costs and and there's really no freight damage unless Gorilla does something wrong with these things. But we had very good luck with shipping these things all over North America. This is just a financial analysis. So what happens typically, a general contractor will budget about $8,500 per zone, and that doesn't include the intangibles such as safety, reduced life cycle costs, standardization, expedited project delivery, labor allocation, labor productivity factors, on-demand shipping, and factory commission. One large general contractor told me this is a no-brainer. This mitigates 20 to 30 risk factors for them. So basically, what's in a zone? So here's your shell and core. Everything from here on the air side is basically your TI, your zone. Here's your loop piping right here, and everything from here's the connections. You can either do this with a sweat connection, but these are hard piped into the loop piping. So this is basically your zone. So you can really figure that what makes up a zone. Typically, you could have a couple of supply diffusers, one return diffuser, $30-$35 a pop. You've had flex duct or round duct going back to the ZCU, so you can kind of run those numbers. A typical controls budget we talked before is $1,400 per zone, and the ZCU budget's about $1,600 per zone. So basically, you can just go through here and you can kind of add these things up. You can sit down and do these yourself, and you can kind of figure out, okay, how much. $8,500 a zone, and then if you go in, put in $1,600 for the ZCU, which includes your controls, your duct, your diffusers, and you should come up to about $5,000. So the takeaway point, kind of like HCA found out, is you could save $1,000 to $3,000 per zone if you allow the controls contractor to supply this. You can see there's some substantial savings, and you might think $2,000, $3,000 or $1,000 isn't a lot. But if you get, 500 of these things, do the math. It adds up pretty quick. And with that, if there's any questions, which I'm sure there is, we're happy to answer the questions. And anyway, let's open it up for questions.